All right, CNT120, Chapter 3, we're going to work on our MAC address. So, a little bit of review what we mentioned earlier. MAC address this is actually the address that's burnt into our NIC, our network adapter. So this is something that is into the hardware on my device to identify this device on a network. This is literally how things like switches find my computer network and send data to just my computer on the network. This is a 48-bit long number. If we were to write it out in binary, it would be 48 bits, 48 ones and zeros long. But you're going to typically find it as 6 hex numbers or 12 hex digits, like you see here. Okay, each of these 2 hex digits here make up a hex number that is 8 bits long. So if I take that, there's 1, 2, 3, 4, 5, 6. 6 times 8 is 48. 48 bits long. Again, this is how nodes on a network find each other, on a LAN, if you will. Switches working at layer 2 check MAC addresses and keep a table of MAC addresses. And it will eventually have a table of this computer's on port 1, this computer's on port 2, this device is on port 3, this MAC address is over here on port 4. So when data comes into the switch, then it knows, ooh, I'm going to pass it out just port 2. I'm just going to pass it out port 4 to get data to that correct device. As we mentioned previously, you're going to find that this has, a bunch of different names to it. I'll get over here. We'll find that our MAC address also has a bunch of other similar names that, depending on the author, depending on the book, they will use different names for it. So I'm kind of throwing them all here just to kind of familiarize and make some connections. Because it's burnt into our actual network card, they tend to call this a physical address or a hardware address because it's burnt into the hardware. It tends to be called an adapter address because it's burnt into the network adapter. People tend to call it a layer 2 or data link layer address because that's the name of the layer where this network card exists, layer 2 or data link layer. And typically we're talking Ethernet NICs connected to Ethernet networks, so we tend to call it an Ethernet address. Okay, most networks are Ethernet, so most network cards are Ethernet, so most will have an Ethernet address burn into them, so tend to call it an Ethernet address. If I were to take network cards out of computers or look at them, a lot of times I actually find it printed on the network card. Here's an example of a wireless one with the MAC address printed onto the motherboard. Here's an older wired NIC. MAC address is actually printed onto, with a sticker onto the motherboard, if you will, of that network card. Here is all those different names we mentioned before. I'm just putting them out here for familiarity. Again, different authors, different speakers, different writers will use different names. It is 48 bits long, as we said before. Here's an example. Okay, so if you see an address like that, you know that's the MAC address, the hardware address, the address of our NIC. This actually has structure to it, a little bit of structure. The first half of the MAC address identifies the manufacturer, organizational unique identifier. So the first half of our MAC address will let you know who made the NIC, who made the network adapter. If we're sitting in our lab room, all 25 computers in our lab room are the same make and model. So the beginning of the MAC address on all 25 computers in the room will be the same number because it's made by the same manufacturer, the same network card manufacturer, if you will. That is actually something that can be looked up. I'll show you that in a minute. The last half of the MAC address, the last 24 bits, is assigned by the vendor. So this should be a unique number assigned to this network card. So the first half is identifying who made it. The second half is unique for that device. So the idea is there's no other network card out there that has this, made by this manufacturer, that has this number for the second half. So it'll be unique. Now, most people start thinking at this point, how is that possible? It is possible over time that you might end up with a duplicate. But the reality is, as long as that duplicate address is not on the same network, not on the same switch, it really won't affect any functioning of that device in the network. If they're on the same switch, then they'll show up as having the same number, you know, having 123 Main Street right next door to 123 Main Street. That's a problem. But if I have 123 Main Street in Harrisburg and 123 Main Street in Mechanicsburg, they're not in the same town. It does not matter. because they are in different towns. So as long as those are not actually on the same switch on the same network, it should not be a problem. But the vendor is responsible for trying to make sure there is not duplicates out there. So if I look at the first half, identifies who made it. The last half is unique to that device, whether it be a printer, a laptop, whatever it happens to be. I can actually look that up. So if I pull up, they reference a tool in here that I can look up a OUI. I can look up who made it. So I'm going to take my computer here, and something I'm going to show you in a little bit. I'm going to show you here. I can actually look up the MAC address. Maybe I don't have that actually as a command, but I'm going to look up the MAC address of my computer right now. If I go to my command prompt on my Windows laptop and do ipconfig/all, I can actually see all the settings on my computer. Now, right now, I'm actually using the wireless card. So my wireless card right here, here is the physical address. This is the MAC address of this wireless card that's in my laptop. This is the MAC address right here. So if I take that number, I should be able to see who manufactured. Well, hopefully, we'll see it's an Intel, but we'll copy that. I want to copy that MAC address, and I will paste it over here into my tool. Let me get to my browser. There we go. I want to paste that in there, and I'm going to say search or find. And right down here, it tells you that beginning FC-C5D4 is an Intel, made by Intel. So if I didn't actually know, I can look at the beginning to know it's an Intel, and then I might be able to go to the Intel site and look up a driver for the NIC if it's not functioning. That's the idea behind this. I can see who made it to maybe go get the driver for it to maybe get this thing functioning if it's not functioning. The point here is, I'll back up a slide. The beginning of the MAC address identifies who made it, and I can actually use that piece of information that can be valuable. As I look closer again at it, this is a 48-bit number, one in binary. Simple MAC address here, sample MAC address here. If I go back to my laptop here, again, ipconfig all. If you're on a Windows machine, we'll bring up my IP configuration of everything, but if I look at my wireless card, in here you see it says physical address. That is the MAC address of my NIC, my wireless NIC. And if I look closer at it, FC, C5, D4, A5, that is a hexadecimal number. And there are 6 hex numbers here, 5C, C5, D4, A5, E6, FA. Those are 6 hex numbers, or 12 hex digits, 12 hex characters, if you will. There is the MAC address that identifies my computer. Now, reminder, don't forget, I do have binary and hexadecimal conversion information on our content page. Use that. We don't do a whole lot with MAC addresses as far as like trying to convert them or anything, but as we'll find out later, hexadecimal gets used in IP6, IP version 6, so a little bit of foundation in hexadecimal will be really helpful in the long run. All right, with MAC addresses, sometimes it's actually handy. I'm going back here to my command prompt again. Sometimes it's handy that I can take this MAC address and plug it into something like my wireless settings on my network to permit this wireless device on the network, or deny it. If I'm trying to filter out, maybe there's a pesky neighbor trying to use your wireless, I could filter this out and say, no, only the MAC addresses of my devices in my house are allowed on my wireless network. So this is actually handy to be able to find, and then sometimes actually plug in settings to filter devices on a network, whether it be wired or wireless. That can be done with your MAC address here. So it is handy to be able to look this up. Oops, I scrolled right by that. There we go. I'm going to keep that handy. Again, MAC address is used to specify a specific node on the network. My PC on the LAN as opposed to your PC on the LAN. And this happens because, or I should say, the device that does this is our switches. They're going to read and make tables of MAC addresses. That way, it knows port 1 has this MAC address on, port 2 has this MAC address on, port 3 has this MAC address on. Now, when new data comes into the switch, it'll read that MAC address and go, oh, I know where this MAC address is on port 2. I only need to send it out port 2. And that's what in the book here, I think they had a couple pictures showing that idea. As data moves into the switch, it makes note of who sent it, and then it references and tries to find where it's going and send it only to that port. So the switch is constantly trying to learn, oh, this MAC address came from here. Okay, I'll put that on my table, and I'm going to send it over to here. Well, I know what it is, so I'll send it out that port. If it doesn't know, it's going to broadcast, and it's going to pay attention. As more traffic comes through, it's going to learn that and put it in its table, so it does not hopefully have to broadcast in the future. Now, real quickly, to kind of get the foundation here, because we're going to talk about IP addresses soon. IP and MAC addresses both get used in the network. And the easiest way I can describe this for you is, when we look at the MAC address, like we've been saying, this is to get it to the correct device on our network, on our switch. So this would be like getting the data to the correct PC at the York campus of Hack. It's really just trying to get it to the right device in that network, in that LAN. This would be like trying to get the letter to the correct person in a house. The letters all got to this house, but now I need to get it to, dad, mom, sister, brother, etc. in the house. This is going to be used to get to the correct person in the house, or in our sense, the correct PC at the York campus network, the York campus LAN. Meanwhile, the IP addresses, we're going to learn a little bit, it's really there to get data to the correct network. We want to get it to the York campus of Hack as opposed to the Gettysburg campus of Hack. So the IP addressing is going to get used by routers to get it routed to the Gettysburg campus or the York campus of Hack. And once it gets in the door, the router's kind of wipes its hands and goes, okay, I'm done. It's up to the switch to get it to the right computer in this network. So keep that in mind as we talk MAC and IP. Both are getting used, but in the grand scheme of things, the IP is getting used to route it through all the networks to get to the York campus as opposed to the Gettysburg campus of Hack. And once it gets in the door, the router's like, okay, I'm done with the IP. Switch, take over and get it to the correct node in this network. If you keep that in mind, a lot of our discussions on these start making sense, or we can keep them sorted out. As we said, MAC address, sometimes you will find that actually printed on your network card. If I'm on a Linux or Apple system, if I use the ifconfig command, you actually can see the Ethernet address. There it is. There's the Ethernet address of this particular device. This is one of my MacBooks I had once upon a time. If I'm on a Windows machine, if I do ipconfig all and look at my Ethernet adapter, whatever one I'm using, in this case, this is a wired one that's getting used. In here, under the physical address, I will see the MAC address. Okay, you notice back here it said Ethernet address, and under Windows it's saying physical address. Like I said, multiple names get used for this. You got to be on your toes. You got to be paying attention. All right, as we come back in the next podcast, we will move on to IP addressing.